Oceans and seas, dynamic, unpredictable, and essential to global commerce, form the foundation of marine and offshore industries. Despite their economic importance, these sectors face constant operational and safety challenges, particularly in transferring personnel between vessels and offshore installations. Walk-to-work gangways have emerged as key engineering solutions to this issue, uniting advanced technology with strict safety standards. Unlike traditional transfer methods, which often involve complex logistics and elevated risk, walk-to-work systems are designed to provide secure, efficient, and weather-resilient access. Far more than a simple passageway, a walk-to-work gangway represents the outcome of rigorous research, precision engineering, and technological innovation. Its development marks a turning point in offshore personnel transfer, combining automation, safety assurance, and real-time monitoring to redefine how crews move and operate at sea. A defining feature of modern walk-to-work gangways is their ability to remain stable despite the vessel's continuous movement. This stability is achieved through advanced motion compensation systems that combine both active and passive technologies to maintain a secure and steady connection between ship and platform. Active motion compensation relies on an array of sensors strategically installed on the gangway and vessel. These sensors detect even the smallest shifts in the vessel's position and transmit data to a central control unit. The system then makes instant mechanical adjustments, counteracting movement in real time to keep the gangway aligned and stable. This precision ensures a safe and uninterrupted bridge under dynamic sea conditions. Passive motion compensation, by contrast, employs hydraulic or mechanical dampening systems to absorb the vessel's movements rather than actively correcting them. While less reactive, it provides consistent stability and reduces the physical stress placed on the gangway structure. Working together, these systems form the backbone of motion control in offshore access technology. The responsiveness of active compensation and the resilience of passive mechanisms collectively guarantee a secure, adaptable connection, enabling personnel to move safely and confidently, even in challenging offshore environments. Safety in offshore operations depends on an integrated approach that addresses every potential hazard in the working environment. A key factor is the installation of slip-resistant flooring, which provides firm traction even in wet conditions and significantly reduces the risk of falls. Equally important are handrails and guardrails, designed not only to provide stability but also to serve as critical barriers in high-risk zones. Their widespread use across gangways and access points greatly lowers the likelihood of accidents, reinforcing a safe and controlled workspace. An emergency release mechanism is another vital component, enabling rapid disengagement from offshore structures such as oil rigs, wind turbines, or other vessels during emergencies. This feature ensures safe evacuation and reduces exposure to hazards during critical situations. To further enhance reliability, redundant grip systems with dual locking mechanisms prevent unintentional disconnection, providing additional assurance of structural security during personnel transfer. Finally, holistic monitoring systems integrate advanced sensors that continuously track environmental conditions, load distribution, and mechanical performance. Real-time diagnostics enable crews to detect and address anomalies immediately, maintaining both personnel safety and the integrity of offshore equipment under demanding conditions. Modern walk-to-work gangways incorporate advanced technologies that redefine safety, monitoring, and operational precision in offshore environments. A key feature is the real-time location system (RTLS), which continuously tracks personnel as they move through the gangway and from offshore platforms, such as oil rigs or wind turbines. Each movement is automatically recorded, providing accurate data on entry and exit times. This constant update of the personnel on board enhances situational awareness and ensures that management always has a current overview of all personnel movements. Complementing this is sensor integration, a system that combines inputs from gyroscopes, accelerometers, and load cells with AI-driven analysis. It monitors gangway performance in real time, detecting platform instability, obstructions, or excessive loads. When irregularities occur, the system can trigger alerts or corrective actions, preventing incidents before they develop and maintaining structural balance throughout operations. A further technological leap is the use of augmented reality (AR). Through AI-enabled devices such as smart glasses, operators can view digital overlays on real-world environments, providing step-by-step operational guidance, maintenance data, or safety instructions directly in their field of vision. Together, these innovations, RTLS tracking, intelligent sensors, and AR support, elevate the walk-to-work concept to a new standard of safety and efficiency. As digital capabilities continue to evolve, future gangway systems will become even more adaptive, predictive, and responsive to the complex demands of offshore operations. As offshore projects expand in scale and complexity, multiple transfer modes are required alongside the walk-to-work gangway. Helicopters provide rapid crew movement over long distances and remain viable when sea states prevent close vessel approach. However, flight operations are weather-dependent, carry lower payloads than marine transfers, and are cost-intensive. Over-water flights also mandate HOOT, helicopter underwater escape training, for all passengers, establishing a hard requirement for preparedness and survivability. Basket transfers return the focus to vessel-based access without a gangway. Personnel stand within a crane-lifted basket for short, targeted movements. This method can be faster than walk-to-work when only a few people must cross or when the vessel cannot maintain stable gangway contact, and it tolerates varied sea conditions. The trade-offs are limited capacity and greater exposure to the elements. Risk controls include safety harness attachment and procedural training for entry, stance, and egress. Selecting among walk-to-work, helicopter, and basket transfer follows operational criteria rather than preference. Distance from shore or adjacent platforms, urgency, prevailing weather and sea state, and the head count or mass of tools and spares shape the decision. This challenge leads directly to a blended strategy in which the W2W gangway anchors routine, high-throughput movements, while aviation and crane basket solutions fill specific logistical gaps, maintaining the central aim of safe, reliable personnel and cargo transfer. Beyond core safety features, several additional factors are essential for the reliable deployment and long-term operation of walk-to-work gangways in offshore environments. Regular inspection and maintenance form the foundation of safe performance. Routine checks for corrosion, structural fatigue, or mechanical wear help preserve integrity and prevent failure under load. Any damage, rust, or deformation must be addressed immediately to ensure stability and longevity. Equally critical is the secure attachment of the gangway to offshore structures. Robust fastening systems must withstand the continuous motion and dynamic stresses of the marine environment, maintaining a stable and resilient connection between vessel and platform. Comprehensive training and communication are indispensable. Personnel should be fully versed in operating procedures, potential hazards, and emergency response actions. Clear instruction builds confidence, reduces misuse, and reinforces a culture of safety awareness. Detailed emergency procedures should define actions for severe weather, equipment malfunctions, or medical incidents. Regular drills ensure all crew members can respond quickly and effectively when real situations occur. Finally, strict adherence to load limitations prevents overstressing the gangway's structural components. Operators must communicate weight restrictions clearly and monitor compliance to avoid instability or failure. Together, these measures, maintenance, secure installation, training, emergency readiness, and load management, sustain the operational safety and efficiency of walk-to-work gangways throughout their service life. Automated crew monitoring uses advanced technologies, such as personal tags, fixed readers, and integrated software, to maintain constant awareness of personnel in complex offshore environments. In emergencies, the ability to identify the precise location of every crew member enables rapid and coordinated response efforts, often determining the difference between risk and rescue. Real-time updates give supervisors and emergency teams the information needed to act decisively and efficiently. Continuous data collection through a real-time location system (RTLS) provides operators and managers with valuable insights into movement patterns, operational bottlenecks, and safety compliance. The system's software aggregates and visualizes data from wearable devices, such as RFID tags or wristbands, offering a live overview of all crew positions. This visibility supports more effective planning, task allocation, and personnel management. A key component of automated monitoring is the emergency alert function. When abnormal conditions or incidents occur, the system immediately notifies responsible personnel, triggering a rapid response. Integrated with electronic mustering e-mustering, it enables swift roll calls and drastically reduces muster times, enhancing both crew safety and emergency preparedness. Offshore operations have evolved from traditional crew transfer methods to advanced, technology-driven systems, marking a major shift in how safety and efficiency are achieved. Although operational risks remain, modern engineering and digital tools have greatly improved the industry's ability to predict, prevent, and manage them. Yet, technology alone is not enough. The human factor, comprehensive training, a deeply rooted safety culture, and adherence to established protocols continues to play a decisive role in maintaining safe operations offshore. Looking ahead, the integration of emerging technologies such as artificial intelligence and augmented reality will further enhance situational awareness, predictive maintenance, and crew safety. The adoption of walk-to-work gangways exemplifies this progress, a clear demonstration of how innovation and human responsibility together drive the offshore industry towards safer and more productive horizons.